Alright folks, welcome to 90.90 Quadratic for your Algebra 2 Chapter 4 test review video, page 3 here. We're going to talk about numbers 19 through 28. This page is all about factoring. So what you want to do here on 19, folks, is ask yourself, is this a single x squared? Anytime we have a single x squared, we want to think about, hey, can I use easy factoring? And easy factoring is this: what multiplies to this constant? This 60, and because this 60 is negative, what multiplies to 60 and differs by 11. We're going to think of subtraction as differing. Differs by 11. So that's a little bit harder. What multiplies to 60 differ by 11? That is going to be 15 and 4. Okay, so you might just need to get that calculator out and try what gives you 60. All right, because the middle term is negative, the bigger factor has to be negative. Negative 15 plus 4, that gives you a negative 11. Not 15 minus 4, that gives you positive 11. So simply our answer is x minus 15, x plus 4. Again, the order doesn't matter. You could have it as x plus 4, x minus 15, but 15 has to be negative. So number 20, what multiplies to 63 because it's negative differs by 2? That'd be 9 and 7. Now notice how the middle term is positive, so that means this 9 is also going to be positive. The bigger factor has the sign of the middle term whenever we have to have a negative and a positive, when we get a negative product. So that means 7 would be negative, so I'm going to have x plus 9 and x minus 7 as my two factors. Okay, folks, same thing here on 21. What multiplies to 56? This time it says plus. This isn't minus. We're not going to say what multiplies to 56 and differs by 15. We're going to say what multiplies to 56 and adds to 15. That's going to be 8 and 7. Notice this is a positive 15, so it's going to be positive 8 and positive 7. All right, and that is simply my answer. Don't set it equal to 0. Don't say solve, but set factor. Okay, folks, notice how there is no middle term, so this is really like x squared plus 0x minus 49. What multiplies to 49, and because it's negative, differs by 0? That'd be 7 and 7. Because I get a negative product, one of these has to be negative. So this is the difference of two perfect squares. So really take the square root of 49. One of the factors is positive, one of them is negative. Okay, guys, on 23 gave us a little bit of an issue, but 23 is very easy. There's no constant, so don't ask yourself what multiplies to 0 differs by 30. Instead, this is kind of what we would do on the AC method on 24 and 28. Instead, ask yourself, all right, what do they have in common? They both are multiples of 5, so take a 5 out. They both have an x. So when you take a 5x out, you're really dividing by 5x. 5 divided by 5 is 1. You had x squared, and you took 1 away, so you're left with a single x. Minus, you had an x, you took it away, no more x's. 30 divided by 5 is 6. And guys, that is your answer. We are done. All right, that one shouldn't be a difficult one. Guys, we're going to wait on 24 and 28. We're going to kind of do them right after each other. So let's take a look at 25 here. Again, anytime you have a single x squared, ask yourself, can I do easy factoring? What multiplies to 90, because it's positive, adds to, negative 19. So what that just means is ask yourself, what multiplies to 90 and adds to 19? That would be 10 and 9. Now 10 and 9, when you multiply, give you positive 90, but they don't give you a negative 19 when you add them. That's why both of these need to be negative. Negative 10 times negative 9 gives you positive 90. Negative 10 plus negative 9 gives you negative 19. So it's going to be x minus 10, x minus 9 as your two factors. All right, guys, on 26, what multiplies to 15? Because 15 is negative, it differs by 2. That would be 5 and 3. The middle term is negative, so the bigger factor's got to be negative. X minus 5, x plus 3 are your two factors. And the last easy factor one we see here is 27. What multiplies to 72? Because it's negative, differs by 1. All right, that would be 9 and 8. The middle term is positive, so the bigger factor is positive. That means 8 is negative, so you're left with x plus 9, x minus 8. All right, folks, let's talk about 24 and 28. You can do guess and check method. That's fine. I'm going to show always the AC method here. You can't really ask yourself what multiplies to 20 and adds to 13. That doesn't exist. This will factor because this 2 is involved here. It's not simply 1x squared. So this 2 is going to do something with that other constant. So that's A. That is C. A times C would be 2 times 20, which is 40. So when I multiply A times that constant, then I can ask myself what multiplies to 40, and because this is a plus, adds to 13. That would be 8, 5. Now the order doesn't matter. I could put 5 and 8, but 8 goes better with 2 because they're both multiples of 2. So I'm going to write 2x squared, and instead of writing 13x, I'm going to write it as 8x and 5x, those two factors of 40. All right, just like I did on 23, I'm going to group these two together. They're both divisible by 2, and they both have an x. So I'm going to divide them both by, I'm going to take an x away from both and divide them both by 2. That leaves me with x plus 4. All right, always bring down this same sign. So plus, these two are divisible by 5, leaving you with x plus 4. These two parentheses should always match up, kind of like reverse distribution. I put x plus 4 together, and these two outsiders, they get to go together. That is a 2x plus 5, and it has been factored. All right, lastly, 28 here, AC method again. A times C. Again, you're going to use AC because if you ask yourself what multiplies to 4 differs by 11, you're not going to find it. So A times C would be 3 times negative 4, which is a negative 12. What multiplies to 12 because it's negative differs by 11? That would be 12 and 1. Now notice how the middle term is positive, so 12, the bigger factor, is positive. So I'm going to put 3x squared plus 12x minus 1x minus 4. What do these two have in common? They're both divisible by 3, and they both have an x. When you divide them both by 3x, you're left with another x plus 4. Always bring down the same sign. So this is a minus. Guys, these don't have anything in common, so if they don't have anything in common, take out a 1. You're really dividing both by negative 1. That's how you get x plus 4. All right, notice how x plus 4, it's not always going to be x plus 4 there. There's one you see twice, so you put them in one ordered pair, and then the outsiders, 3x minus 1, get to go in the other ordered pair. All right, folks, I'll tell you on Monday how many factoring questions you're going to have. I think about 5 or 6. So that's it for 19 through 28, page 3 of your test review video. This is 90.9 the quadratic, signing out.